So students, welcome back, and let us look at this series. 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 blah 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 blah. So it just keeps on going like that. Now this series, as we know, it is an AP, right? Because 1 plus 1 is 2, 2 plus 1 is 3. The difference between each of these consecutive terms is 1. The common difference is 1. So it is an AP. So suppose there are n terms, okay, and if my question is to find the sum of the series, you all know how to do it because you know what is the sum of an AP, the formula for to find the sum of an AP, that is an arithmetic progression. So the formula is A plus L, that is the first term plus last term, into the number of terms, that is n, whole divided by 2. Perfect. So let us just substitute the values. The number of terms is n. It is still n because we don't know. We are just finding it for n terms. First term A is 1, and the last term is we don't know because if there are n terms, so see, the first term is 1, the second term is 2, third term is 3, fourth term is 4. So we can guess that the nth term is n. So the last term will be n. And thus we have a formula. Sn is equal to n into 1 plus n by 2. Perfect. Now, this is the sum of this type of an AP. But what if my series was like this? It was a sum of squares. That is, sum of squares of natural numbers. 1 square plus 2 square plus 3 square plus 4 square. And I think you would say just use the same formula. So we can write Sn is equal to first term plus last term whole multiplied by the number of terms n whole divided by 2, right? First term is 1 square is 1, last term is n square because all these are squares. So we would say yes, we found the answer, but that is wrong. So why is it wrong? So let me tell you, because this formula Sn is equal to first term plus last term multiplied by number of terms whole divided by 2 is only for an AP. Is this an AP? Now 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16, 5 square is 25, 6 square is 36. Now students, if you check the difference between the consecutive terms, 4 minus 1 is 3, 9 minus 4 is 5, 16 minus 9 is 7, 25 minus 16 is 11, 9. And so you see that the difference just keeps increasing. So there is no common difference. And if there is no common difference, it is not an AP. Also, if it is not an AP, then we cannot use this formula. Do you understand it? So therefore, we have to look for some other thing to do. And it is not a GP also, because 4 by 1 is not equal to 9 by 4. It is not equal to 16 by 9, obviously. So what shall we do? The same thing happens for this type of series, cube series. 1 cube plus 2 cube plus 3 cube plus 4 cube. Again, it is not an AP because 1 cube is 1, 2 cube is 8, 3 cube is 27, 4 cube is 64, 5 cube is 125. Just keeps on going way high. So what shall we do? To answer that question, we need to let me take you here. So a special series. Now this is the answer that is given in your textbook. Okay, so it is given directly in your textbook. Of course the textbook gives a proof, but this is the formula that is directly given to you. N into n plus 1 into 2n plus 1 whole divided by 6, and then Sn is equal to n square into n plus 1 whole square whole divided by 4. So they give you the direct formulas of squares of sums and the squares of cubes. So the choice is up to you, students. You could study this. 1 plus 2 plus 3 plus 4, I showed you already how it came. The sum of square series, that is 1 square plus 2 square plus 3 square into n square, you can study this formula, and cube series you can study this formula. So it is up to you, students, whether, but no, not up to you, you should study one of the ways, but I would like to introduce to you another way, another method in which you can find the find the sum or find the formula for the last term or the sum of the series, but by of any type of series, whether it be a cube series or it is a fourth power series or fifth power series, or even if it is not a power series. So I would like to show you such a method in the that will be what will be following in the rest of the video or videos. But if you're not interested in it, you can stop the video now, because this is the answer to what we saw. Okay, but if you're really interested in knowing the method on how to find by yourself a formula, then please continue watching the video. Okay, so this was, look at this series, 5 plus 11 plus 19 plus 29 plus 41. Okay, now is it an AP? Let us check. 11 minus 5 is 6, 19 minus 11 is 8. Oh, nope. 29 minus 9 is 10. Okay. 41 minus 29 is 12. Okay, that is not an AP. Obviously, it is not an AP. So that doesn't work. Is it a GP? 11 by 5, 19 by 11. Oh no, it is not equal. So there is no common ratio. There is no common difference. So it is not 10 AP. Right. But let us okay, before I go to that, I need to show you something, and I need to make you have studied this before or you have seen this before, but I just want to make it sure that it is there in your memory. Linear expression is in the form ax plus b, right? For example, the equation of a straight line, y is equal to mx plus c. Quadratic expression, you studied this in the chapter complex numbers and quadratic equations. It is usually not usually, it's always written in the form ax square plus bx plus c, where a and b, c are all constants and x is the variable. So this is the usual format in which you write, for example, 2x square plus 3x plus 4, or 3x square plus 5x plus 6, anything like that. You already seen this thing. Now this I doubt you might have seen or not. Cubic expression is written in the format like this: ax cube plus bx square plus cx plus c. It's nothing different. You just start with the highest power. You have already studied binomial theorem, so you might be familiar with this. You start with the highest power of the variable and then keep decreasing the power. The last will be x to the power 0. X to the power 0 is 1. That is why there is no x here. So a, b, c, d, all this the blue letters, a, b, c, d are all, constants. So keep this in mind. So with this base or with this foundation only, we can apply this method. Now let us take the difference of the difference. That is, let us check the difference between these differences. So 8 minus x is 2. Okay, 10 minus 8 is 2, 12 minus 10 is 2. So do you see something here? Even though this is not at 5, 11, 19, 29, 41, it is not an AP, because the differences are not the same. But the difference of the difference, the difference of the differences are the same. It's an interesting thing. Now let me tell you one thing that you should know. If this is the second level, right? The first level here, we took the first level of differences, it is not same. The second level of differences, that means we took the difference of the differences, they are the same. So this will be in the form of a quadratic equation. Okay, the same thing, if this was the case, if these numbers, that the first level differences, if those were really same, if those were the same numbers, for example, there was common ratio, for example 6 6 6 6, if it all were the same numbers, then it would be a linear expression. So it is just like that, first level of differences, if it was the same, it would be linear expression. The second level of expressions, if it was the same, it would be quadratic. And suppose it was not the same, we could go down again and take the third level of differences, and that would be so then if that is the same, then these numbers 5 11 19, all these numbers are in the form of cubic equation. Let me make it all clear to you. Let us go for a linear equation. Take this series, for example, 5 7 9 11 13. What are the differences? 7 minus 5 2, 9 minus 5 9 minus 7 2, 11 minus 9 2, 13 minus 11 2. So we see there's a common difference. So according to what we just saw, this should be a linear equation, right? Because the first level of differences are same. So what is the form of a linear expression? So by the way, this 5 7 9 11 13, it is an AP, right? Common difference too. So you studied that any number in the AP series can be written in this form, a plus n minus 1d, right? Where n is that term, the number of that term, specific term. Now the format of a linear equation is ax plus b, right? This I can write it as b plus ax, same thing. Now look at that. It is the same format, right? A is a constant, it's the first number, 7. First number, that is 5. So that is b is a constant. Then a is a constant, which is d here. D is a constant, right? Because d is a common ratio, it doesn't change. It's a ratio, it's a common thing, it's the same thing. So d is a constant, and that is your a. And what is your x? Your variable is n minus 1, because n value you are deciding what it is. You are deciding, there is no fixed value for n. You can put whatever value for n you want. So the n minus 1, that whole thing is a variable. So that is your x. So do you see that what you studied as an AP comes in the same format of a linear expression, b plus ax. b plus ax. Okay. So do you see that what I told you is true? So let us come back to the previous. So I put the color coding so that you can see it. Let us come back to our original thing. So I told you, because these 2 are the same, it is a quadratic equation, and quadratic equation means it should be in this format, ax square plus bx plus c, right? Now students, this might be a little long, but if you take time to practice it, and if not practice it more, if you might have to rewatch the video once again. But let me tell you that it will be very beneficial for you in the sense you don't have to by heart many formulas like that. You just have to learn this method and you can make your own formulas. Okay, so you would understand that by the end of this video and the end of one or two more videos that you might come after this. Okay, so please keep watching with patience and try to get interested in what we are doing. Okay, even though it might feel a little boring in the beginning, but by the time you reach the end of it, I do think that you'll be interested. Okay, anyways, so ax square plus bx plus c, that is the format of a quadratic equation. Now we don't know what is a, b and c, right? We don't know. That we have to find out. Then only we'll get the specific formula. Now in the previous example, of course, a and b, we came to know what a and b are, but that is for this specific case, right? That is for this specific case, but for this expression we don't know what they are, so we need to find them. Now with this formula, what I was trying to say is we can find any term of the series. Now, so that variable should not be x, it should be n. In our case it is n, right? Because our variable is not x, our variable is n. N is the number of the term which is our variable. So we'll put the variables like this, and with that we will, so first term, so we can find any of the terms in the series. The first term is 5, so we can say maybe this is equal 11, 19, 29, 41. We can find any of the terms. Now let's take the first term, 5. So I can say this is equal to 5. So when I substitute some value for n, I will get 5. When I substitute some other value for n, I will get 11. And when I substitute some other value for n, I will get 19. Okay, let us see what all this thing is a little more closely. So let me take you here. This is what we just saw, right? So n square plus bn plus c, n square plus bn plus c. We saw that that formula will give us any of the number of those series when we put the right value for n. So what is the value for n for 5? We know that it is the first term of the series, so n is equal to 1. So let me substitute n is equal to 1. 1 square, n square, that is 1 square is 1. Then n, that is 1 itself, and 1a 1b, I don't have to write 1, it's the coefficient is 1, you can take it off. So it is a beautiful formula you get, a plus b plus c is equal to 5. What about the second case for 11? Here n is equal to 2, so n square is 2 square, that is 4, n is 2, and that is done. The third case, n is equal to 3, with 19 is the third term. So n square is 3 square 9, n is 3, and you get you get all these three equations. Now as I told you, you need to find the value for a, b and c, so that you need to know what those a, b and c, what those constants are, so that you can make the specific formula through which you can find any term. Okay, so let us solve this. So let me subtract these things. 9a, so subtract these two equations. So when I subtract these two equations, I get 9a minus 4a, that is 5a, plus b, and c minus, this is c minus c gets cancelled. I'm subtracting these two equations. So 9 minus 4a 5a, 3b minus 2b b, c minus c becomes 0, and 19 minus 11 becomes 8. Okay, now let me put that equation here in the right side. Let me store it for something else. Now I want you to subtract these two equations. So I'm trying to take the easiest of the equations, so that you can subtract easily and you can understand well. So subtracting these two, you get 3a minus plus b is equal to 6. That is 4a minus a, 3a, 2b minus b, b, c minus c 0, 11 minus 5, 6. So let me put that here. Now you have, so let me subtract these two equations now. So when I'm subtracting these two, I will get 5 minus 3a, 5a minus 3a, that is 2a, plus b minus b, that is 0, is equal to 8 minus 6, that is 2. Okay, so I got a single, I got an equation with only one constant, that is 2a is equal to 2. So let me find what the value of a will be. So a is 2 by 2, and that is a is equal to 1. Now substitute the value for a is equal to 1 in this equation. So it will be 3 plus 3 into 1 plus b is equal to 6, and from that find the answer for b, and b you will get it as 3. You should also do this, okay? Do it by yourself so you can understand how it works. And you have now the value of a and b. Put those two values in this equation. A plus b is equal to c is equal to 5. You could put it in any of this. You could put it in this 4a plus 2b plus c, You could put it in that also. There is no issues. I just took a plus b plus c is equal to 5 because it is easy. It is easier to, it's a easy equation. So then you get c is equal to 1. So you got the value for a, you got the value for b, you got the value for c. So now you can find any number. So this was our quadratic expression, right? an square plus bn plus c, and we got the value for a, b and c, and a is 1, b is 3, c is 1. So 1 n square, I can write it as n square. So this is your formula, and with this you can find any number in the series. For example, you need the first term of the series. Suppose first term was 5, right? So let us check. N square, 1 square plus 3n plus 1. So 1 square plus 3 plus 1. 1 plus 3 plus 1. 5. So you can check for yourself, substitute any number for n, and you can see that it will come the same number in the series. Okay. So this is what so this is, I know it's a little long method, but with this you can find anything. So we see that we get this beautiful expression. Now I would like to continue, and I would like to find out the formula for this series, but if I do it in the same video it will be a little difficult for you. I mean, it will be a little long for you to watch. So what I would say is, I'll stop the video here, and the next video I will show you how to, we'll continue with this thing. I would like you to practice what you just saw, so that you will really understand and you will be clear in your mind what we just did. Okay, it requires this thing requires practice. Okay, so thank you for listening. See you in the next video.